The coefficient of determination, or R squared, is the portion of total variation in the dependent or target variable, explained by variation in the independent variable. The values of R squared are between 0 and 1. Basically, R squared is the regression sum of squares divided by the total sum of squares. The charts on the left side show the perfectly linear relationship between x and y. In this case, R squared is equal to 1. All the variation in y is explained by variation in x. The charts in the middle shows weaker linear relationship between x and y. In this case, some but not all of the variation in y is explained by variation in x. And finally, the chart on the right side shows no linear relationship between x and y. In this case, the value of y does not depend on x. Once we change a model, how do we know if we have a good fit or not? The standard error of estimate is used for this purpose, and basically it is the square root of error sum of squares divided by n minus 2. And here is the number of observations in the training dataset. Low values of standard error of estimate shows good fit. For example, the chart on the left. In this chart, we can see points are very close around the regression line. Looking at the chart on the right side, we see more variation of points around the regression line. So here we have a higher standard error of estimate, and this is not a good fit. Does y depend on x? Let's form two hypotheses, H0 and H1. And again, here we have simple linear regression. So there's only one coefficient for one single variable. In H0, beta 1 is equal to 0. This means there is no linear relationship at all. In H1, beta 1 is not equal to 0, and here it indicates there is linear relationship between the independent and dependent variables. In R, you can use a summary function given a model, which gives the result of a t-test. The first column shows the estimates for B0 and B1. The second column shows the standard error. The third column shows the t-values for B0 and B1. And finally, the last column shows the p-value, which is the probability that the true parameter greater than the absolute value of the t-value. As we have low p-value here, so we reject the null hypothesis. And we accept the alternative hypothesis, which says there is a linear relationship between x and y. Then we conclude that there is statistical evidence to support that sales is linearly related to advertising. And here we note that B1 is a change in sales for a change of 1 in advertising.